Okay, welcome back. This is November 2020 higher numeracy here. So we got a tricky little question here, arcs and angles. This is deep in the paper. I'm pretty sure it's towards the end. I don't remember any questions in this. Yeah, it's actually the second last question if I'm not wrong. Yeah, it's number 11 here, so these are going to be the hard questions. We've got a 2-mark here, which is okay. So we just got to look at this quite simply here and think we're looking at arcs and sectors. So we've got to use the numbers we got. So we just got to remember there's 110. This goes across here to that 85. So I'm just going to take this diagram and I'm going to put it in my into my professional software that I'm using. Something like that. So it's about there. I'm just going to get the question in there as well. So why not? And box that in. So we can already go and say that 110 is there and that 110 is there. So we've got the radius already of this. But we need to find out, so we know what the area or the perimeter as well. We're looking for the perimeter here. So we know what the perimeter of a circle is already. It's pi d, right? So we'll have to times 110 by 2. 110 times 2 is 220. So that's our d. But we've got a sector here. So, or an arc. So we'll have to take 85 and put that over 360. That gives us a fraction of 360. A fraction of the entire circle, which we can then times perimeter by. So let's just find the perimeter. That's pi d, pi times 220. And I just put on my calculator. I can't show you here because it doesn't have it on screen. Actually, I can because I do remember pi to a couple of digits. So 3.14159265 rhymes nicely, so you can remember that if you ever forget it. Times 220, and we've got 691. So that would be for the entire circle, not just this arc. So that would be assuming this circle went the whole way around. That would be our area. If we times this then by 85 over 360, that fraction should give us just this arc's length. So let's times that by, I'm just going to do that on my calculator actually because it's not very useful on this screen here. So that I'm just literally going to write in this, exactly what I put here. So 691.15 times 85 over 360. That's 163.18. We're just going to put 19. Like that. So that's our, that's our distance. So it says calculate the distance that point A travels, but let's just keep in mind that literally is the same thing as, oh, that's a perfect line, look at that. That's just the same thing as the arc length. So it's the distance that point A travels. You can think that's the length, which way it goes through the through space. Being close to fully open. That's your answer there in centimeters, because we're using centimeters here. Okay, so I'm just going to clear that out. And then on to the next one, which is a bit tougher. So a thin rod is used to hold the trapdoor open in this position. The rod goes from closed position, point A, to the point in the edge of the trapdoor. So to find the length of this actual, of the rod, we need to use the cosine rule. I love this rule. It's very fun to remember, because it seems really hard, but it's not actually that bad. So I'm just going to write it down really quickly next to our workings. Cosine rule is a squared. It's going to be really big. It's really tough to write this down quite small. A squared equals b squared plus c squared minus 2bc cos a. And we can see we've got the numbers for that because that goes there. We're using a minus 16 from the 110, so 110 minus 16 is what? 94. And just 110 there. So we've got b and c, we've got our cos a, and this length here is a. So all we need to do is put the numbers in. So a squared is going to be, let's just say b is 94 squared plus 110 squared minus 2, 94, 110 cos 85 degrees. And I'm literally just going to put that in my calculator, for anything from there. I'm going to put that in and see what it gives me. So 1 sec. Okay, so that gives me 19,103. You might panic and go, wait, what? That's completely wrong. Must be. But then obviously, you've got to square root it to get our A. Square root of answer. is 138 centimeters, which makes sense because it should be longer than these two lengths because it is, no, I wouldn't say a hypotenuse, that's not true. It would make sense to be the longest here. Okay, so that's 138, 3, 2. Okay, so we've got the first part, we've got the length down. Length is all good. We've got that. Just gonna write, I'm gonna clear this, but I'm also gonna write it down. Oh, come on. What was it 138.32? So I'm just gonna paste this in again. And zoom in a little bit. 138.32 cm for our rod here. Now we can use the sine rule to find out the angle that it makes. So it's asking for the angle it makes with the horizontal. So the horizontal is referring to this plane here, okay? So we want this angle here. And we can use my favorite rule ever, which is the sine rule, because it's really easy. The sine rule would say that we can take this like this. We got 80, oh, come on, 85 degrees. And we've just worked out this, so it's 138. And then for this angle, we just need something to correspond with it. So that would be this one, 94. We've taken away that 16, 110, 94 cm. Then all we got to do is just say that because we're working on angle, we've got to put the first angle we've got on top. So it's sine 85 over the number it's associated, which is 138.32. And then always times it by the angle associated with what you're trying to work out. So we gotta times it by 94. And then we can just put that on our calculator. So it's literally just what I've wrote there. Sine 85 over 138.32 times that by 94. And then we'll get a really small number. So we just need to shift minus on the sign of the answer. And that gives us a thing. So we got 0.6769, blah, 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 blah. And then all I do is just go shift on the sign, sign minus 1 of that equals 42.61 degrees. There you go, that's the angle. So we've got the length and we've got the angle, just like that. So that's quite a bit of thinking that question requires. It's a tough one, definitely an end of paper question, but just got to use your rules, your trigonometric rules, your sine rule, your cos rule. Just apply them where you see fit.